Also, I have
Okay, let me give you right
maybe I can.
screen. Okay, share your screen now. Let me see what you have done.
Okay. I download this
Okay, this is your
SD file.
STL. Okay.
Yeah, yes. I was practicing in this folder in motorbike.
Okay.
Maybe I was that since I don't know if it's correct that I uh, sorry, sorry. Okay, is that
Okay.
I changed the name,
Okay.
right event, and also in that refinement box, I don't know if it's okay the box that
Tell me the dimensions of your geometry. Can you open ParaView?
I put also
Check its
1 second.
dimension.
Okay, access script.
Okay, it is has maximum of 70 along x direction. Okay. Can you just give me rights from here? Uh, okay.
Okay,
So the maximum direction is 75 along x-axis and along y-axis is maximum 50 and along z is 37. That is from 16 to 53. Can I just move it? Okay, this is their geometry. Okay, what about the block mesh? Can you open block mesh?
okay,
First of all, escape, close it and open your block mesh.
okay. I gonna close that.
Open your block mesh.
I don't. Sorry. I can't.
Press escape, shift, colon WQ.
I don't get.
Open block mesh. BIM, BIM space block mesh.
I think that I never put that.
Okay, now first of all, change this. You have not changed this.
No,
So
I haven't changed that.
you have didn't
Okay.
change your block mesh file. Okay, are you getting my point? The first point is that you have to change your block mesh dictionary according to your STL file. I think you have not changed your STL block mesh. In order to check your geometry, first of all, you have to define your block mesh. You have not defined your block mesh. Define this according to your STL. Did you see my last lecture?
Yes. Okay.
I have
Yeah.
I have told in that lecture that first of all you have to change the block mesh for your snappy X mesh. Okay,
Okay, well.
change it.
Um, a ver, according to uh, 0, 0, 0, axis A. I guess it's that thing. I guess 0, 0. Cito, cito, cito.
Go ahead, hurry up, change it, hurry up.
I guess that.
Okay, now run.
I think I put the same in that cache.
It's depend upon you, whatever you want.
Yes. Okay, four. Uh,
Open in ParaView.
Wow. I think that I not have the.
Go back to your terminal and make a file.
I forget that thing. Is xform.com that thing?
Touch space name it and dot form.
Mm. Okay.
This is your STL file.
No, it's my blog.
Block mesh. Sorry, this is your block mesh. Can you see
Yes, yes.
how many errors this has right now?
There are 1, 2, 4 errors, I guess.
Okay. Now open your STL. Also enable your STL file here. Now you can see. Just change it. And your file is still outside of this block. Okay.
Okay, okay. Maybe more bigger.
Okay, let me just give me right. Let me check how can I make it my good. Accept it. So, system. Okay. The maximum displacement from X is 74. So the minimum point is 0 and maximum is 74. Let me first of all set these two points. 0, 0, 0. You have still not set their name, okay? You have to also set their names.
Mhm.
Five, 6, 7. Okay.
Okay, Wally.
Next step is not 70. This point might be, but let me set it in.
Maybe 80.
Okay. And then this is 150. What about the point is along y direction? So the maximum point along its 50, 0 to 50. Let me just change it to 70.
Okay.
So the maximum point along this case is 70. Okay, so not about this is 0 and this is 70. to both the points 0, 1, 2, 3 about that is the maximum point is 37. Let us just do to 60.
60 maybe.
Point number 60 and 150. Then the next line 150, 50 and 70. Okay. So the last
That in
60.
70. Why change that? Well, it in point number 4 you put 0060. In 550. Okay. 7 also have.
Okay, now copy and paste at your desktop.
Okay.
Copy and paste at your desktop. Enable apply. Give me your remote access control.
Okay.
Okay, now can you see? But this
Mhm.
the first point is still at here. Now we also change the first point here. Also we need to change the long x-axis and y-axis. Then we can just give this thing to boundary condition and we can start our mesh. Okay, are you getting my point?
Yes. Yes, buddy.
Okay. Now let me just stop this song and give sorry. Press mode control. Let me minimize this thing. Open the control terminal. Sir, now see this system. Sir, VIM space PLOCK. And now let me change this to 0. Just 1 second. Let me enable. Just 1 second, Joseph. Okay.
No problem, buddy.
Okay. Now, okay, now copy and paste at your desktop. You need to do all these things by yourself, okay? Right now I am doing.
Okay, got it. Okay.
Okay, just lower its capacity at the top, little above. No, not this one, not this one, not
Not
this
here.
one. What are you doing, Joseph?
Opacity is not touching.
I think you're not getting my point right now. What you have done? This is the capacity, okay?
Ah, okay.
Now you can
I
see,
believe I believe that was in the last part of the program.
okay? But you can see still it is a little up. We need to change its direction in Y, okay? So the
Mhm.
only thing matters is we need to change its direction along Y is in positive. So in positive, we have to add little more direction so we can perform our simulation, okay? Now change its direction in positive Y and then we will move towards snappy exponential. So just open your you want to terminal. Let me just tell you quickly. Here, see the system. Yes, block mistake. Okay. Now just simply go to Y. You can see here it is a 60. Change this 60 to 90. Escape, shift colon, update. Space. Okay, now copy and paste at your desktop. Now you can see. Open it. Okay, okay. Apply. Now low its capacity. Yes, this one. Yes. Okay. Now little move it. Okay, now I think it is a good. We don't need to change, but still it is not good. But the thing, our main purpose is to do right now simulation or perform snappy exmesh. Okay, right now it is a good. Now close it and just open your snappy exmesh. Let us move first of all your snappy exmesh. Close it. Close where you open your snappy exmesh CD system. Just go into the directory system. CD system. Open snappy exmesh. Okay, first of all, let me check whether this file is present in constant directory or not. Press escape, shift colon WQ. Press escape, shift colon WQ. LS here. Enter. Now CD space dot dot. Enter. LS here. Now write cd space constant see enter lsr. Now open try services, write cd space trie
Try
trie.
surface.
Yes, lsr. We have not spaced any file still now. Just let me, what should I do? First of all, you need to copy your file in this directory, okay? Right here, explorer.exe.x.
Okay.
Now minimize it, minimize this, minimize. Now copy this your STL file, copy your STL file, copy. Now open that thing which we have first open. Now open the yes, this one. Open the last one. Yes, try something spaced here. Okay, now delete readme. Delete readme. Delete readme. You can see here readme. Right click and delete it. Okay, now close it. Open Ubuntu terminal. Open your Ubuntu terminal. ls here. You can see you have a file RIND. First of all, let it change its name. Let access. Now I'm going to change its name. Okay, accept it. Now the thing is, this mv is the command to change name. Okay, now I'm just going to use change name. mv space rid dot stl is file file dot stl. Okay, ls here. Okay, first of all, minimize it and let me check this file whether this is a good stl file or not. First, the first step is I have forgotten. Let me open with which this is open with.
Yes. Yes.
Okay, open with this notepad. No, this is not this. This will not work in OpenFOAM. Okay,
Mm-hmm.
this
Okay. Okay.
because we cannot see anything here. Okay, you can see it's still here. We cannot work anything here. This is a not good file. Let me stop this for you. We cannot start snappy image because the STL file is not good. Let me just give off my controls. Okay, now stop your sharing screen. Let me show you which type of STL file should be. Okay,
Okay, buddy.
share. Now you can see my screen.
Yes, I can see.
Okay, now let me tell you about. Yes, this was the file which we have downloaded. Yes. Let me open with this with the notepad. Let it open, then I will show you. It is taking too much time right now. Oh my god. Let me open this. This is the so I think this is corrupted right now. This file is corrupted, okay? If it yes, it is corrupted now. We cannot still use this file for okay. So this small render cannot be used. For let me just open anything else. I have an popular folder. Let me open this file for you. Open with. Okay. Yes, now can you see?
Yes, yes, Wally.
This is how
Okay.
an STL SolidWorks should start from here and face it normal. And this file will be work, and anything else will not work in your case. For example, I have opened a small liner. You can see there are too many errors in that case. So in order to work, since your file work like this, okay.
Okay, Wally.
So have you any file of STL like this?
I don't have any file.
Okay. Let me just check in my Ubuntu terminal which thing I have. Be simple as I want a simple ls cd constant ls cd fly surface ls vam arrow.stl. So we cannot use this file. Okay, you can see there are a lot of errors here. So that was the
Mm-hmm.
case when our mesh is not good. Okay,
Okay, Wally.
so we have to define any STL geometry for our usage. Okay.
Mm-hmm.
Okay, let me just give you an. I have an file of propeller. For example, what should I do? Okay, let me remove from here. RM minus RF VX extended feature unless RM minus RF poly PL poly mesh okay unless RM RM no RM CD TRI dry surface LS RN minus RF AER and store. Okay. LS now both files are removed. Let me yes LS here and write explorder dot exe space dot. Okay. Now I'm just going to copy the propeller file because I have not any else file right now. Okay.
Mm-hmm. Okay, Wally.
Drop I have copied this and now I'm going to paste it here and paste it. PROP. Okay. Now let me just open my Ubuntu terminal once again. LS here. Now let me go to cd dot and ls here. cd space dot ls here. Now let me go to my system directory cd system ls and open my. First of all, let me check my block mesh. This is the first step to check
Mm-hmm.
block mesh. Let me run here PLO feature block MESH block mesh. Okay. Okay, block mesh is written. Now let me write here explorder dot exe space and dot enter. Now let me copy them and paste at my desktop. Copy. Okay, I have copied them, minimize them, and I'm going to paste it here. Okay. So this is going to be pasted right now. Let me open my ParaView until this is copied. Okay. So just 1 second. It should work. Okay. Here is it. Now let me open my desktop and there is a simple code. Yes, there it is. Let I have opened AB form. Okay. And now I'm going to apply. Now you can see this is my by default geometry. Okay. And let me open my geometry inside in it. What was that geometry? That geometry was pro.stl. Okay. And now I have applied. Now I cannot see it now. The what was my purpose? Let click over this and change this into
Okay.
change prestige. Okay. This. Okay, now you can see my
Mm-hmm.
STL geometry was here. Is it outside? Let me just complete it. No, it is still in inside. Okay,
Yes, it's inside.
this is inside. Now I'm going to just uh, simply name it and just perform a simulation right now. I'm not going to do anything else here. Okay, this is closed, this will be closed. Let me open this ls here. Now simply go to system directory, cd system ls. Now open my snappy mesh sna snappy mesh. Okay, and what about the my quality parameter? First of all, I'm going to just name it prop.stl. Okay, so this was my name. You can see here in simple car in constant directory in try surfaces, the name is prop.stl. Okay, so I'm
Good.
going to name this prop.stl.
Mhm.
Where is it? Yeah, you can see
Yes.
the name is here is arrow.
Prop. Error.
Change this name to prop.
Mhm.
Prop.
ROP.
Okay, and then
Yes.
this is like
The
this.
name arrow.
Oh yes,
Sorry.
yes, we
Prop.
have change arrow, change this arrow to pop. Okay,
Mhm.
RO pop. Okay, now leave this thing because these are the already things that we have changed. Let increase its this thing. We want a good
Uh-huh.
match. Let's do this to a 5. Okay.
Also the name arrow dot
Yes,
dot
yes, yes, yes,
image.
yes. Arrow dot mesh to pop down. Good. And this to pop PROP pop dot image. Okay. Now change this name of arrow to prop PROP and give this name to 5 by 6. Okay.
Mhm.
So the in group the type wall is arrow, prop not arrow. PROP prop. Okay. Okay. So the only mesh snap is good. Snap is good. We are not going to add layer. So no, no.
Levels. Okay. Levels. Arrow. Layers.
Yes,
Here. Prop.
PROP. Okay. But we are going to just of this. We don't need any layer around this geometry, okay? Because this is not where we need layers. We'll off layers and then we will perform. Then let me just simply pause this pause and through this true and also through this true. Let it escape if column WQ. Alas, now let me open VIM surface feature extract. Surface feature extract. I have to also change arrow.stl name to prop.stl. Okay.
Mhm.
Arrow.stl.
Okay.
This prop prop.stl and now escape shift colon WQ. Now CD dot ls here. Now first what step is I have run block mesh. Now my second is surface. SURF surface surface FTA extract EX. Okay, now let me click. Okay, all things are written. Good. No need to change. Let me ls here. Now let me run snappy x double snappy h EXX MESX mesh minus OER over WRID. Okay. Okay,
Mhm.
this is how we can just run our snappy head mesh in this case. I have just clicked. Now let's see what happens. Okay, walls is added. Okay, it is doing good. Yes, it is performing its feature iterations. Look like everything is going fine. Okay, good, good. Till now there is no anything here. It's going good, very good. Surface refinement is also going good. 2 by
Mhm.
3. There is no any error still up till. It is going fast. Uh, surface iteration 4. We can also run. Okay, let me stop here. Let me stop here for you. Now the main point is here that we can also run this thing in parallel. Let me just show you the CD system. In system directory, there we have a file decompose paradigm where it is
Decompose.
VIM space DCM
Decom
decompose paradigm. Okay, so the total number are defined here 8 and the method is hierarchical and the coefficient are VC 2 I have defined it in this way. Let me just space it and let me just go back to that directly and write here decompose DCM decompose bar and enter. Now you can see 8 different processors are written here in this file. Do is not equal to now. Okay, leave it. We are not going for the cell, but the first thing is we have just defined our 8 cores. Okay, so the name of the
Okay, Walid.
that is like this. Okay, right here.
From 0 to 7.
Now we are just going to run our mesh on 8 different cores. Now ls here, you can see total 8 different codes are here. So what the
Yes.
command is mpi run mpi run minus ovr our subscribe scribe our subscribe mpi run minus np space 8 and then snappy snappy hex
X mesh.
Yes, mesh minus
Override.
O V R over W R I T override and then minus parallel P A R A double L E. Now let me run and check if it error comes any. Yes, no error is coming. It is running fast. Okay. Now you see.
Okay.
Scores are coming fast. Let me just check whether this is working good. U V U N P. Now let me open this and see here whether my 8 codes are working or not working. Let me open this Ubuntu terminal. I think it is going very fast right now because it is working at 8 processor.
After the running in parallel, it's necessary to join all the
Now you
all the
can see.
running.
Now can you see here at the percentage usage is 100 and 300%, and this is a snappy exam match. It is running at 8 different codes. Okay, in this
Yes,
file you
yes.
can clearly see that it is working on different cores. So this is the process how we can just run our snappy X mesh on multiple cores, and this will basically increase the speed of our snappy X mesh. It is clearly seen from this present that this is running very fast as compared to the previous one. Okay.
Okay, what is?
So this is this thing is not included in this course, but still I have give you an overview how we can just run. Okay. So for example, in your case, it will take too much time to first of all install MPI and then to perform these functions. Okay.
Okay, what is?
So the only thing is you have to download. Let me just give you a file. So you have only download one file. Okay, Joseph, and you have to work on that file for some time. For example, download any file from internet, whether it is an aeroplane, whether it is a jet plane, what type of aeroplane. Okay, so you have to perform your snappy hex mesh machine by using these commands. Okay.
Okay, what is? I see that.
Just wait for 1 second. I think it will be completed in 1 or 2 minutes. Okay.
Okay, what is? Finish.
Okay. ls space sample card and ls. Now you can see these four all processor are working in a very good. You can see it's written your first night tingling and now it is activating. In this case, it is going very well. And in this, from here we can also see a stop and see our. You can see here it is a snappy X mesh and it is running our command like this. Okay, snappy X mesh minus override minus parallel. You can also see your things from here. Okay.
Okay, Walid.
And from here you can see all 8 codes are working 100% with efficiency. Okay.
Yes, yes, yes.
And
Full
total
of.
threads are 8 running and tasks are 16, 28 student load average. Everything is clear mentioned here that you can see our whole things are working very good right now. Now you can see it very good. So this was the command which we have given in our MPI run minus our subscribe minus NP8 snappy xmatch minus override minus parallel. By defining this, we are performing our overall functions here in our this case, and it is very good now. It is executing. So now it is, I think, we have to approximate it is going to finish. We don't need any heavy type of mesh. So I think it's just removing basic. You can see there is no error coming here and doing final balancing. I think it is completed approximately. Yes, the first one is completed. Now it is going to just snap. So the first part is approximately completed. The second part is started from here. So when you see that this type of scaling iteration is happening, so this means that the first part is completed and the second is started from here. Okay.
Okay, Wally.
So it means snapping of the mesh is started from here.
Mhm.
It will snap your whole geometry. For example, your geometry is the propeller, and that propeller is now snapping. Your mesh is just snapping at the surface of your propeller.
Mhm. Okay. It's possible that I show you what I need to do.
Sorry.
It's possible to that I show you what warning on warning will play.
Sorry, I cannot understand you. What are you saying?
It's possible to that I show you that for example, is
Okay, sure.
uh,
Let me just stop my sharing screen so you can share your screen and show me what you want to show me.
I use that. For example, I want to moderate Paul's media
Okay.
from. I also have no that's the first simulation of phone. Or what's the first part of the phone? And also how to mesh complex geometry with a snappy hash mesh.
Yes.
And also it's the first part
Yes.
that we are working. The equations. Okay, this is the first
Yes.
part of that
These
set.
are the things which I've already told you. Okay.
Yes, yes. It's also the enter head diffusion that I don't want to do. Want to do.
Yes, these are the basic setups in the open form. This is the cavity setup. Okay. So this is the
Mhm.
directions and this is the geometry. They are just in Gedit is the editor. We are using Vim right now. They are using Gedit for system block mesh directory. This is how they just create first walls. Okay.
Okay, yes, Walid, yes. Also, we do that.
This is the, for example, this is the flow in the laminar. So the assumptions, for example, this is the density. You can bring, this is the density right now here, 0.01.
Mhm.
Okay.
Yes, yes. Then it's also
These
part
are
of.
the control setups here.
Uh-huh.
Control setups
The,
here. Okay. These are, I will also show you these from Monday. We can start working on these all contours. Okay.
okay. Then this is a Poselius flow. So that also I am working with that. Inlet, outlet, similar of we work.
I
This
can
is
also
the.
explain you all these things in post processing. Okay.
Mhm. Okay, okay. But also it started from drainage and capillary tube. Okay,
Okay.
that's in change the vertices, uh, refine them in some of parts. Also, the phases, no, water, oil.
There are two phases of where, for example, if you are using volume of fluid or VOF, then in VOF you have to define where the layer is water and the where the layer of air is. Okay.
Okay, Oli, yes. And also after that is that thing, no? Snappy hash mesh.
Yes, that is a snappy X mesh. It read all these file .stl or .obj. There, these are two main factor. And right now we have just castle, and this is the part in number 3. You can see it can just
Uh-huh.
snaps. Okay.
Okay.
Here just
Then I want to build that geometry, no? Solid grain by surface mesh file. That things I want to do. Uh, in your opinion, is necessary that I build solid grains in?
you need solid drains inside your geometry.
Okay, also inside, but this solid grain is necessary to build in
Let me just
cat
see.
file in cat
Mesh by
program.
void space porous medium with snappy edge mesh. Void spaces needed that to be grinded and solid grain defined by a surface mesh file. So you need a surface mesh file of these grained. If you have a surface file of these file, then you can define it here. Okay.
Mhm. Okay.
Are you getting my point, Joseph? For example, if you have to define these solid grains, you can see in the green color, the all grain which are in a green color, you have to model it in any modeling software. For example, SolidWorks, whether it is a SolidWorks or any other software, because it is difficult to create in here in block mesh. So the only thing is you need to define it by a solid surface. When you just define it, then you just use by using snappy hacks, like you can simply put them in your try surface, and then you can mesh your all these trains. Okay.
Okay, okay. But is in your opinion or in your advice will be that I need to build in SolidWorks maybe or in other program
Yes,
to.
you can also use them in any other program. You can use in a SolidWorks or a machine and any type of modeling software where you can just made any a CAD STL of these file. So the only thing you need is the CAD geometry, CAD.stl file of these grains. Okay.
Okay, okay. Well, then also it's that
Yes,
part that I,
yes, these type you can see here. These are the STL file. Can you
yes, it's
zoom it? Can
it's
you zoom it?
mhm.
Can you zoom in? You can, okay, sorry, sorry, you can see it. There is it is. It is say that download exo5.stl and copy folder to view the geometry. You can see you can download exo5.stl. Okay. When you download, you can just open and paste.
I looking for, but I couldn't find that. It's not available, I
It
guess.
is not available. So you have to model it. Okay.
Uh-huh.
So
Yes,
you
for
have
more than that.
so you have to make in your any modeling software. So this is the file you required for your simulations. Okay.
Okay.
Are you getting my
I
point or not?
not totally what it
What are you not getting my point?
the last part I couldn't understand very well.
So this is the thing that you have to model in. You have to make your own geometry of these grain in any modeling software, whether it is a SolidWorks. SolidWorks is a software where you can model these. Or if you want to make in a Gambit, you can also make in a Gambit. And if you want to make in a NCS design modeler, you can. It's depend upon you. You have to model or you have to make an STL file or STL geometry of these grains. Okay.
Okay, okay, well,
This was my point. Okay.
okay, okay.
Now stop the sharing screen.
Then also change the X match that we don't know. Snap, true, false.
These are
Or,
the properties which you can define. You have not to do anything. They are just simply, but you can just simply click on them. It will automatically create. First, you need exo5.stl for your mesh. Okay, you have to make it by
uh-huh.
your own self.
Okay.
Okay,
Then
now
this is
stop your
the
sharing screen. Stop it. Let's first. Let me just share my screen.
Okay, Wally.
Now share. Now you can see here the mesh is completed. Okay, it has a little error. You can see here it is a 104 error, which is right to a mesh, and you can see in here it is also completed. Now let me check the quality of a mesh. Okay. Uh, check mesh. Check mesh minus all geometry. Geometry minus all topology. Okay. Now let me check if it has failed. No, nothing will be failed. I think all thing is good. Simply let me run check mesh. I think mesh is good. Now ls. Now let me see where is. Now let me write here reconstruct mesh. RCON reconstruct para reconstruct parameter. Enable it. What is this? Not well tested tolerance. Form existing construct. Why this should not? This should work. Reconstruct.
Reconstruct para, I guess. Para mesh. Okay. No.
Construct parameter minus over our SUB sub S SUB sub S construct para parameter. Why this is not working? This is an experimental tool which provides an individual processor pushes back into the master uses the region meshes that has been deleted if the processor meshes and topology change. This is used for building mesh step and construct and regenerate. Not well tested and use it so this from your current setting as specify ASCII setting with 6-digit precision. Please change the right format to increase the binary reconstruct para mesh. I think we cannot use this in our case, okay? But this is the way. I think I have not specified any slot. Let me just continue CD constant. I cannot construct it here. CD walk 7 CD CMS. Yes, it is written here, but we cannot change this thing back into reconstruct right now in this terminal. Let me just find it. Okay, we cannot use it. Okay, Joseph, in this terminal, we cannot use this reconstruct paramesh. We cannot. So the only thing is right now we have to define a slots. Right now in my PC, I didn't have defined any slots. Okay, and the process of definition slot is a little time, so we cannot use it in a here case. We can define it by any other case. Okay.
Okay, Wally.
Okay. Up till now, if you have any question, you can ask me.
No, I want to do that. It's show.
Okay. Now your homework is you have to download any STL geometry from online, and then you have to make a mesh. And on Monday I will check it. Okay.
Okay, Wally. Okay.
Okay. Up till now, then take care. Bye bye.
Okay. See you Monday, Wally.
Okay, Joseph. Take care.
Take care.